Hello, fam. I just realized that these problems are called check for understanding, not check your understanding. So I'm going to need to fix that in the videos that I already uploaded. This is for lesson 73. Let me just verify that really quick because now I'm starting to feel like maybe I'm not right. Yeah, so this is the check for understanding for lesson 73. We only had one paper of problems, so hopefully that wasn't too bad. 65 just wanted you to check conditions. I have my conditions here. I really should add on to number 65, large counts condition is met. So the CLT applies and we can do a t-test. Or we can calculate a t probability or something along those lines. I think it's really important that you understand why you're checking these conditions. So the randomness is so that you can generalize to the population or make inference about the population. Your 10% condition is so that you can calculate spread. And your large counts is so that you can actually use the pink table to calculate your probability. 69, we were asked to calculate the test statistic, find the test statistic on the table, and then find the true p-value using our calculator. So I will go through this problem and the next one step for step, and then on the next problem I'm just going to have you compare your answer to mine, and if there are any lingering questions then you can ask me during class time or send me an email. I just need to grab my calculator off the floor. I dropped it earlier. Okay, so we calculate our test statistic. And since we know that we're going to need to put this in our calculator, I'm just going to do that now to have my calculator find this for me. So I'm going to go into Stat. I'm going to arrow over to Tests, and I'm going to choose option 2. My null is 115. And because we don't have our hypotheses down, I'm using this as my guide. So 115, my sample was 125.7, my standard deviation is 49.8, and my sample size is 45. So it looks like I already had that data in. We are checking to see if these students have better attitudes. Higher scores indicate more positive, so we are doing a greater than test. We're doing a greater than test. So I can calculate, and I get a t of 2409. and a p-value of 0.0101. So I'm kind of doing this as like a sandwich. So now I'm going to get the range from my table. There is no 44 on our pink table, so I'm going to use 40, and I am looking for what two values 2.409 falls between. So I'm going to row 40, it's right underneath a gray section, and I am looking for 2409. 2409. So 409 is very close to 423, the lower number would be 2123. So 409 is between 123 and 423. So I'm going to follow this up, and that gives me a range of probabilities from 1% to 2%. However, I know that it's going to be very, very close to 1% because 1% is 423 and we got 409. So it's much closer to this probability. And that's what we end up getting from our calculator, that it's very, very close to 1%. So I have that written down here, and I just made a note to myself that it's very close to 0.01. For our multiple choice problem, they give us our t-value and the sample size. So we're going to look at a degrees of freedom of 19. That actually is on our table. And we're going to look up a t of 225. Or 2.25. Even though our t is negative 2.25, it is okay for us to look up the absolute value of that to get our probability. So we're going to the 19 row. So it's in a gray section. And I'm looking for 2.25. Okay. So 2.25 would be 250. So to help myself out here, I'm just going to add a 0 on to the end of this number. So I'm really looking for what two values I'm going to think of it as 250 is between. So at this row, I have 93. That's 93 and 205. That's too low. So then 205 and 539. So it would be between these two. Mine is 250. So it's going to be closer to 2%. So my option is 205 to 539. Well, 250 is much closer to this one. So my probability is between 1 and 2, but it's going to be much closer to 2. So that answer is A. Then our last problem is running a t-test given a set of data. So I set mine up a little bit differently than I did in class, and I mentioned this in the last video, and I think it's worth mentioning again. There is nothing on this paper that can be left off except for this normal probability plot. Everything else you must have. We need to get in the habit or have the understanding that they're looking for very specific things on the free response problems, and where you guys want to take shortcuts, often I want to take shortcuts. So if I'm taking the time to write out this big old long process, it's because it's necessary. I try to only teach you the things that are absolutely necessary because there's so much to know. So please keep in mind that as you compare your answer to my answer, you need to have all the things, family, except for this. So like I said, I did this a little bit differently. Because they gave me the data set, I just automatically pulled my stats that I knew I would need. So my sample mean, my standard deviation, I listed my sample size, and I thought, well, I might as well do my degrees of freedom while I'm at it. And then in that same window, the one variable stats window, I pulled my 5-number summary. So I got this from one variable stats, and I got this from one variable stats, and double checking that there were no outliers. Although this looks to be right skewed, especially the center 50% of the data, it does look quite skewed. It doesn't have outliers. So that's the most important thing that I am getting from this box plot. I'm not really going to mention anything about it being symmetric or skewed because I'm a little bit unsure about whether this is too strongly skewed. So I'm going to stick with what I know for sure I can't have, and that's no outliers. Because this was so skewed, I checked the NPP. And once I looked at the normal probability plot, I realized that it is okay to assume the population is normal because this definitely has a linear form. This definitely has linear form. So even if you don't graph the NPP, but you use it to help you make your decision, so maybe you did exactly what I did. You looked at the box plot and then you were like, oh, I don't know about that. So then you checked the NPP but didn't graph it. You probably should still mention it in your response if you did check it. So that all being said, here is my state and my plan. My state and my plan. This defining the variable was very difficult for me. I erased several times trying to get the right wording. So I'm mentioning that for you guys to know. You just do the best that you can. Then notice here I have mentioned my box plot and my normal probability plot. So if you checked the NPP, maybe you should say NPP, do a little note that says not graphed, show that it is reasonable. My p-value, remember I've asked you guys to find both just so that you have the practice. So if you're using the table, your percent is from 1% to, just kidding, your percent, okay, family, these numbers are so small. So here's how I'm going to think about these. I'm going to add on a number to the end. So these are both 4 decimals. So here's how I'm thinking about this. My number, my true p-value is between 5 and 10, but I know it's a really small number. It's between 5 and 10. So this would be 6. The true value is 6, so it is between 5 and 10. What percents are these really? Well, this is 0.05%, and this is 0.1%. So those numbers are very, very, very small. Muy small, very small. Okay, and then my conclusion, I took up too much room, so I had to tape my conclusion on because, you know, problem solving. I wanted it all to be on the same page, but I didn't want a Post-it note covering up part of my problem, so I taped it on. And then once again, the conclusion, it was so hard for me to get the right wording, so hopefully it was a little easier for you than it was for me. One thing to note is that holy moly, our alternative is that it's less than 8. So I framed my conclusion based off of the alternative. So we have convincing evidence that it is less than 8, not equal to 8. Okay, like I've said in hopefully every video, if you have questions, email me or ask me in class. We're getting so close to the exam. This is so important for what you will see on your actual exam, that it's so imperative, it is necessary that you do not move forward with any misunderstandings. So any questions about this, please don't hesitate to ask. I'm happy to help. Yeah, that's it.